Hey guys, welcome to Code Dork. Today we are going to solve a problem which was asked in the Amazon interview, and the level of this problem is hard. Okay, so let's check out the statement. It says check if the value exists in a level order sorted complete binary tree. So what does complete binary tree means? That except for the last level, okay, have a look over here. All the nodes have two children except for the last level. Okay, means the last level might be filled completely or might not be filled completely. This means a complete binary tree. And what does level order sorted means? Okay, I'll try to explain. Check out the right node of each level. Okay, all the elements down to this level, means below this level, below, all the elements are greater than 15. Here all the elements are greater than 35. Okay, this means a level order sorted complete binary tree, and we have to perform a searching on this tree. Okay, we don't have to perform a standard searching where we have to traverse each node. You have to apply some logic and an algorithm. So the rest all steps are same, that if 3 is present, then if 3 is not present, we return no. 7 is present, yeah, is the root node itself. 30, yes, it is present over here. So let's check out the intuition first, and then we will move on to the code. Okay, here I've written down a binary tree which is level order sorted, obviously, and I've written down the levels. Okay, each level is 0, 1, 2, 3. So and these are the 4 functions which we have to construct, and I'll explain them to you guys, how these functions are being constructed and how they are useful. Okay, so let's suppose we have to find out the element 25. I write down over here element 25. Okay, so our first function, find level. What does find level does? It finds, or it gives us an estimation that if this element is present in our binary tree, it will be present at this level only. Okay, how does it find that? It starts from a root node and it keeps on traversing only to its left, okay, until it encounters a null value. Okay, this is the first termination condition. I'll write down here, find level. First termination condition is if it encounters a null value. Second termination condition is, this is 32. Okay, the second termination condition is if it encounters a value which is greater than the element which we have to find. Like in this case, it will encounter 32 over here, and the value of 32 is greater than 25. So it will get terminated over here. And when it gets terminated, so 32 is present at level 3. We will also keep a track of that in this function. Okay, it will return level -1. Why level -1? Because this element is greater than 25. So if 25 is present, it will be present at the level prior. So it will return us 2. Okay, it will return 2. This was the first case in this function. Now let's take another case. Okay, in another case, let's suppose I have to find out the element 13. Again, it will do the same. It will traverse to its left. But now what happens here is, while traversing, it encounters 13 itself. It encounters the value 13 itself. It means that the value 13 is present in a binary tree. So in this case, it returns level is -2. Why -2? Because it is giving assurance that yes, I have encountered this value and it is present in the binary tree. Now you might say that okay, we can even return a positive value. If I return a positive value, then my main function will assume that this element is present in that level. Okay, and it will perform searching on that level. But no, I am saying that this element is present in the binary tree. That's why I'm returning -2. Now you guys might say, okay, then we can even return -1. Why not -1? Okay, I'll come to that even. Let's suppose I'm trying to find out the element 4. Okay, the element 4. I start from the root, and what I see is that the root element is greater than the element which you have to find. So think logically, if the root is greater than the element which I want to find, will that element be present anywhere in my complete tree? No, it will not be present, obviously. It is sorted. So in this case, I have written -1, stating that this element is not present in the tree, and I am sure about that. Now you guys understood why I am not doing it for -1 and -2. Okay. So let's jump back to example 25. Okay. So you guys understood the first function, which is find level. Now comes our second function, binary search. I just write the abbreviation BS over here. Okay. Now in binary search, it will have the level at which the element might be present. Okay. I'm using the word might. It's not an assurance. It's just the thing that it might be present at that level. Okay. Now, how you guys find out that how many elements are present in that level? Okay, the maximum limit. The formula is 2 to the power of level. At which level we want to find that? Like 2 to the power 2 is 4. Okay, so at level 2, how many elements are present? 4 elements are present at level 2. We can find it out by this formula. As you can see, 1, 2, 3 and 4. 4 elements are present at this level. So why I named the function binary search? You guys might have struck something that, okay, we are going to apply binary search, blah blah. Why are we applying binary search? This is level order sorted. This is sorted. So we should take the advantage of that. Okay, instead of performing a linear search, if we can perform a binary search, it will be beneficial for us. Okay, so now I've got how many elements are there at a particular level, as 4, and at which level I have to find? It's level 2. I write it out cleanly over here. My level is 2. Okay, now we are performing binary search, right? So standard binary search will have start, it will have mid, and it will have an end. So start will be 0 and end will be 3. Why 3? Because number of elements present -1, like is 0 based indexing. So 0, 1, 2 and 3. So what will be the mid is start plus end divided by 2. Means 0 plus 3 divided by 2, it will be 1. Okay. So now I will pass what parameters. Now I have to find the gray code. What does gray code means? Okay, this is the important part. So just note it down somewhere that left denotes 0 and right denotes 1. 0, 0, 1, 0, 1, 1. So now if I have to instruct my program that you have to go to this destination, what I will tell him that go 1, 1. 1, 1 means right from the root and you will reach this destination. If you want to go to 25, go first right and then left, means 1, 0. This is how I will instruct my program. Okay, you guys might have understood, otherwise you can just rewind and check. So what I call this is, I call this as a gray code. A gray code for my function, that it will give me a path to which destination I have to travel. So how can I find the gray code? The important part. Third function. Okay, our third function. What will the parameters for this function is the level and the mid value. Why level? We will find out. Okay. So in this function, I will have a variable called as level tracker. It will be assigned to 0 and I will have a list over here. Okay. So what this level tracker is, you will come to know in this function. So what I will do is, in the list what I will store the value of mid mod 2. So until this mid is greater than 0, what I will do is mid modulus 2 and then mid divided by 2. Okay, so what my value of mid is? First 1. So 1 modulus 2 is 1 and then 1 gets divided by 2, so it changes to 0. So is 0 greater than 0? No, this also changes to 1 when I insert the value here. So now what this tells us that the value of level tracker and level is not matching. It means with this gray code only I cannot reach to this particular level. And to reach to the particular level, what I will do is level minus level tracker. Level minus level tracker. I will insert this many zeros in my list. So 2 minus 1 is 1. I will insert 1 0 in this list. Now what is the value of my gray code? My value of gray code is 1 0. But you guys might say, but this is not the value which we want. If we want to reach this index, we need 0 1, not 1 0. But this is the opposite. Why? Because we are starting from this index in this case. Okay. So what you have to do is we have to just reverse this value, and this becomes 0 comma 1. I will pass this value to my function traverse. Traverse is a simple function. It will just operate on this code, and it will go to this destination and check if the value is present or not. If the value is present, it will return yes, the value is present, and yeah, tada, function ends. If the value is less, in this case the value is less, then we will perform binary search over here. Okay, so I will remove this over here. So now what my value of start is? Now my value of start will be 2. Why? Mid plus 1, right? Mid plus 1, and my value of end will be 4. Sorry, 3. 3 plus 2 is 5. 5 divided by 2 is 2. My value of mid is 2. Okay. So again we have to come to the function of gray code. We will again find the gray code. The level is 2 and the mid is 2. I have a list over here and a level tracker over here. What is 2 mod 2? 2 mod 2 is 0. Count over here is 1. And what is 2 divided by 2 is 1. 1 is greater than 0. Yes. Again 1 mod 2 is 1. Count is 2. And 0 is greater than 0 because I'll divide it by 2 and it will become 0. 0 is not greater than 0. Function terminates. Value of level tracker. Value of level tracker is equals to value of level. So yes, with this gray code I can go to level 2. I will reverse this. Again I mentioned why I will reverse. It will be 1 0. I will pass this to this. Okay. After doing that, it will come 1 0 25. Tada! We have found the value, and this is how it will be calculated. This is only these 4 functions we have to implement. Okay. So if you guys have any doubt or something, you can mention in the comment box and I will try to resolve that doubt or create another video for explanation. So let's jump to the code. This is my main function over here. I have constructed a binary tree with this, and these are the values we are finding: 25, 8 and 51. 25, 8 and 51 is not present, so let's check it out if it works or not. So first of all, I'm finding the level. At which level? As I mentioned, our first function is find level. Okay. After that, if -1 means it's not present, -2 means it's present. Then this is the binary search function. This is the start. This is my end, and this is the data value you have to find and the level. And this is the route from which I'll start searching. So I just said while end is greater than start, and I'll find the mid, and here this is the gray code, generating gray code, and I will store it in an array list. This is the function to generate gray code. As I said, while this is my mid and this is my level. While my mid is greater than 0, what I will do, as I said, mod 2, I will divide it and I will keep a level track over here, and I will reverse this as I said. Okay, and see, if I have not reached my particular level, then I will add zeros. In this case I have already reversed the list, so that's why I am appending zeros at the start. Okay, and after that I will return this array list. After returning the array list, I will pass it to the traverse path function, which comes over here. As I said, if it's 0, it will go to the left. Okay, as I said, if it's 0, it will go to the left. If it's 1, it will go to the right. Okay, and what this incomplete path means that, suppose I have a path, a gray code named 1, 1 and 1. Is this possible in this tree? It is not possible in this tree, right? 1, 1, 1. It's not possible. Only 1, 1 is possible. So in that case, it will return -1 if that position is not present in my binary tree. Okay, you get it? So from here, if the value is present, see, I'm checking here is, if the value is present, then I return this root over here. If the element is -1, then I will perform the check in the left subtree. If the value is equals to the data which I am finding, then I return true. If it is greater, then the right part. Okay. So, and otherwise, if the condition fails, and I return false. So this is how this algorithm is working. So let's check out the output. See, the output is 2, -2 and 3. In the first case, it is 2. Why it is 2? What was our first example? It was 25. As I said, 25, it is present at level 2. Okay. And -2 for 8. Why? It is present in the left subtree. It means it was already encountered. And for 51, it is passing 3. Now you guys might be saying that 51 is not present. But this is only assuming that if it might be present at level 3 or no other level. That's why it returned 3. But finally it returned no. So if you guys understood this concept, the intuition, please give a like to the video, because it takes some efforts to get the content and make this video. I really appreciate the like, and please share this with your friends and do subscribe to my channel. Thank you and stay safe.